Yes, guys, are getting the voice?
Is okay? What speaker? No problem? Better let me bring the speaker. Yes. Okay. You can reduce the fan speeds. Right, fine. Fine now. So, as already we have completed the weekend question. Now we will discuss few numericals, guys, based on combination of resistors and cells together. So have you received the worksheet? No. I said without receiving the worksheet don't come, right? Ask for you guys to go and collect, sit there and collect it. Today? Okay, try to get it. Okay, fine then, because you cannot practice more questions without worksheet. So let me dictate if it is a smaller question and if it is required. Otherwise, for few questions, you can understand the question by looking at the circuit itself. Okay? Specifically, how to find the resistance, equivalent resistance of resistors connected in infinite network. Okay? So these kind of questions are given in level 2 exercise 1 and 2s. So let us do one question here. Okay? Infinite network. You have a chart? No chart, please. Where? Can someone put the staff room? So the question is the equivalent resistance between points A and B of an infinite network of resistance each of 1 ohm connected as shown in figure is. So let us see the figure first, then we can try to understand how to work it out. While coming across these infinite networks, one particular basic element will be repeating number of times, infinite number of times. So you have to first identify what is that basic element which is repeating, which is repetitive. Just a second, guys. Yes. There is no start with box, sir. Right. Yes, guys. Online students, I hope the voice is clear for you guys and the board is also clear. If any problem is there, you can drop a message in the chat box, guys. If voice is not clear or board is not clear, if you get any problem like the screen is blurred, you try to check your settings. So go to the download part and you can in the settings part, view it in high resolution part, high resolution settings. Right. Okay, guys. Now let us discuss one question based on combination of resistors. That is level 2 exercise 1. Level 2 exercise 1. Question number 24. The question is the equivalent resistance between points A and B of an infinite network of resistance, each of 1 ohm, connected as shown in figure is. So here a point A is given, here a point B is given. Between these, the resistors are connected as shown in figure, like this, and these are going up to infinity. And here at this junction, from this point, there is no resistor is connected. And here again identical resistors are connected like this. And it is going up to infinity. So if you observe this, the one of the basic element which is repeating. So what is that repetitive element? You have to identify first to work out this kind of questions. All are identical resistors. 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm. Right? So you have to identify the repetitive element. If you see, this R and R is one element. This is that kind of similar element is repeating here. That same kind of element is repeating here. So this is the repetitive element. You can keep this aside first. So now all these other elements we have to replace with one resistor by considering one small logic. That logic is, if you consider just if you add one bucket of water into ocean, the level of ocean will not change, right? Same way, if there is infinite such elements, to those infinite elements of this RR, if you add this element, let us say it's the total resistance we don't know, so let us say its resistance is some X. If you add this element to that, the effective resistance will not change. Yes? So let us consider that the total or effective resistance of this remaining part of infinite network is X. And let us redraw this as, this is R and R. So this is A, this is B. This resistance, the entire remaining part we are replacing with X. This is 1 ohm, this is 1 ohm. Identical, you can take in general R and R also. So you can take this is R and R, at the end you can substitute the value of R. Okay? Now, if you add this section to this, the total resistance or complete resistance of this infinite network will be X. That means resistance between A and B also will be X only. Are you following this? So what is that X we want to find? So for that purpose, now let us come back to this point and let us consider if this is some current is coming here, this two will divide the current in these two vertical sections. So this X and R are said to be in parallel. So find the effective resistance of these two. So what you will get? R into X by R plus X. So then again redraw this. This is A, this is R, and this resistor, these two we can replace with one single resistor, that is nothing but Rx by R plus X. This is also R and this is B. We are not taking the numerical values. At the end we will substitute the numerical value. Okay. Now, so this and this are in series. So the effective resistance between A and B is also equal to X. So R plus this, if current comes here, the same. So these two are said to be in series. So we can say R equivalent. That is the equivalent resistance between A and B, which is nothing but X, which is equal to this plus this. What is that? R plus Rx by R plus X. Did you understand this step? These steps one by one, everyone? So try to note down this, copy it down, and now simplify this to get the value of X in terms of R. So this X is equal to this. Now if you simplify this further, you can write this as a cross multiply. R into this becomes R square plus Rx. R square plus Rx. Here plus Rx, one more Rx is there, divided by R plus X is equal to X. Directly let us take this as X. That is nothing but effective resistance between A and B, that you have to find X. Okay. Now again if you cross multiply, you will get Rx plus X square is equal to R square plus Rx plus Rx. 2Rx. Is it here? So here we are supposed to find X. So X is our variable. So we have to write this in terms of X square, keep it here. This 2Rx you bring here. It becomes Rx minus 2Rx minus Rx minus R square is equal to 0. This is in the form of a quadratic equation. If you solve this and if you find the roots of quadratic equation for X, then you will get the effective resistance between A and B. In terms of R, then we substitute R value, then we will get numerical value. So what is this? You have to remember roots of quadratic equation. The roots of quadratic equation. If the quadratic equation is in the form of x square plus bx plus c form, x square plus bx plus c is equal to 0 form, then you will get x is equal to minus b plus r minus square root of b square minus 4ac by 2a. So that will be your roots. So it gives you two values. So you can take this as x is equal to, in place of here ax square plus bx plus c, if you compare, in place of a we have 1, in place of b we have minus r, c you have minus r square. You substitute this, you will get minus b. What is b? Minus r. So minus of minus plus r minus square root of b square means minus r whole square, r square minus 4, a is 1, c is minus r square. So minus of minus plus 4 r square. So you get what? R square plus 4 r square by 2a. A is 1, 2. So here plus or minus will there. If you take plus, we get one root minus another root. So let us take this is 5 r square. R square you take it out, so it becomes r root 5 or root 5r. So root 5 is 2 point something. So if you take negative value, so you will get r minus root something 2.1 or 2.2 r means you will get negative value for resistance. So resistance cannot be negative. So no need to consider the negative root. So let us consider positive root. So it is equal to r plus square root of r square plus 4 r square by 2. Yes. So here, you can take this as 5 root 5 into r directly. R also you can take this out. R you can take out and you can write 1 plus root 5 by 2. So here substitute the value of r. You will get the final expression. Final answer. You see the options. You get because r is equal to 1 plus root 5 by 2 will be your answer. Okay. So I hope for online students the voice is clear, because I have observed that the voice was not clear with that already existing system. I have changed this. I hope everything is clear for you guys now. If anyone is facing any issue, voice issue or clarity issue, you can drop a message. Right guys, finished? Can I erase this part? Next, and another important method of questions you should have an idea about here in case of combination of resistors is, of course we have discussed a few other combination of resistors questions. We will see one by one. Right. You see, so listen, those who are not having the worksheet, listen the question and they can note down the data. The question is, and you can write down the question. This you have to write down. A uniform wire of resistance 20 ohm. A uniform wire of resistance 20 ohm having a uniform wire of resistance 20 ohm having resistance 1 ohm per meter, having resistance 1 ohm per meter is bent in the form of a circle, is bent in the form of a circle, is bent in the form of a circle as shown in figure. I will give you the figure. If the equivalent resistance between, M and N is 1.8 ohm, 1.8 ohm, then length of the shorter section is, length of the shorter section is, length of the shorter section length of the shorter section is right guys. Let me give you the diagram first. The figure is, we have, this is question number 12 in same level 2 exercise 1. So the question is, we have a wire which is bent in the form of a circular wire, it is bent in the form of a circle, so that somewhere here we have marked point M and here point N, and this is given to some from these points a connection is given to two wires, so that the current is entering into this part here and it is leaving from this lead of the wire. So what you can understand, what else is given here is, it is given that a uniform wire of resistance 20 ohm is given. It is a uniform wire. So from one of the concept of dependency of resistance and dimensions, we know resistance is directly proportional to length. So we have to make use of that here. Okay. It is given that R is equal to 20 ohm and it is also having resistance of 1 ohm per meter. It is also having resistance of 1 ohm per meter, means R by L is equal to 1 ohm per meter. Did you understand? As R is equal to 20 ohm, can you find the total length? So total L is equal to, you can say R by 1, R is 20, so you can say it is nothing but 20 meter. 20 ohm by 1 ohm per meter, ohm cancel here, meter. So the total length of the wire should be 20 meter, it is a uniform wire. So for every length, if you take mean for it, this total length is 20 meter, this will be divided this into 1 like that. For every 1 meter, resistance is 1 ohm. 1 ohm per every 1 meter it is having. So the total resistance is 20 ohm. That is the meaning of it. Right. Now it is when that wire is bent into the circle, and if you mark these 2 points, the effective resistance or equivalent resistance between M and N is 1.8 ohm. 1.8 ohm. Effective resistance between Mn is equal to 1.8 ohm. Then length of the shorter section, bend this total length L into this. So in this, this will have a larger part of the wire and this smaller part of the wire. What is this smaller part of the length of the smaller part is the question. So what you have to understand is, if you consider current is flowing here, it divides into I1 and I2 at this junction. So these 2 parts are said to be in parallel. These 2 parts are said to be in parallel. So you can consider these 2 are 2 resistors. 2 resistors in parallel. Got it? 2 resistors, they say this is R1, this is R2. So effective resistance is R1, R2 by R1 plus R2. So but you don't know what is this, what is the length of this. So let us say total length is here. In this length of the shorter section is X. Right? Then what about this length? L. Actually, if it is L minus X you can take, but actually L minus X. But it is total circumference should be equal to 2 pi r. Anyway, that r, if it is required, you can take in that form also. So, but total length, if you observe, this is x part of total length, means the remaining part of the length will be L minus x. Got it? So, by making use of these, what do you call, length proportional to resistance relation, we can consider these 2 as 2 resistors in parallel, and you can find the value of x. So, L is given 20 meters. How can you find then? When 2 resistors are in parallel, equivalent resistance is R1 R2 by R1 plus R2. Can you find out this? Let's try yourself. Take a minute and try yourself. Fast. So R between M and N is this. If it is, this is resistance of this part is R1, resistance of this part is R2 if it is. And directly here in terms of length only you can take that because resistance is directly proportional to length, because R is equal to rho L by A. R is equal to rho L by A. If area of the uniform wire means area will be fixed. If made of same material means resistivity will be fixed. So you can take this because of this. You can also take, so you have in terms of x's, you can take R1 is nothing but L minus x into R2 is nothing but x you can take in terms of length. Then it should be R1 plus R2 means L minus x plus x. This gives you total length is equal to equivalent resistance. Equivalent resistance, right? So if you take this as 1.8 ohm, then what will you get? You take this, you equate this, 1.8 is equal to, L value is 20, total length is 20, you take in terms, substitute those also, 20 minus x into x by 20. So you multiply this, 1.8 into 20 is, so 2 into 10 is 18 into 2 is 36. So 36 is equal to 20x minus x square. So this is also a quadratic equation. You can write this as you bring it here, then you will get x square minus 20x plus 36 is equal to 0. So solve this and find out x value. Roots of quadratic equation. Let's try yourself, find out that. How much? 8? 18 or 2. So if you find out the value of x by taking the roots of quadratic equation, this only the general formula, x is equal to minus b plus or minus square root of b square minus 4ac by 2a form, will get x is equal to 18 comma 2. 18 comma 2. So 18 will be the length of the larger section, 2 will be the length of shorter section. If the question is, what is the length of shorter section is the question. So you can say your answer should be 2 meters. Length of shorter section. Length of shorter section is equal to x is equal to 2 meters. Is equal to 2 meters. Right? This is how you have to work out this kind of questions. These are also answered in the previous years of different competitive exams. So you need to have an idea of this as well. Next, to find the effective resistance based questions, let us see one more. Then we will see one cells combination based questions. Right? Is that finished, everyone? This side. Look into the next question. Question number. This is similar kind of question we have discussed already. Let me see. Can you give the answer for this or not? The question is equivalent resistance across A and B in the given circuit is. Equivalent resistance across, if you want, you can write the question. The equivalent resistance across A and B in the given circuit is. Question number 25. What is the resistance between A and B? What RAB? For the given figure. The figure is having point A here and point B here. So that we have between A and B two resistors like this, and here let us say this is midpoint, and to this midpoint here we have one resistor here and one more resistor here in a triangular form, and to the midpoint here, so if you form a triangular kind of shape, one more resistor here, one resistor here, between these two vertices one more resistor is connected, and it is given that all are identical resistors. It is RRR, these RRR and R. So what is the resistance between A and B? We are asked to find. So already we have discussed these kind of questions. While finding the effective resistance between any two points, we have to assume an imaginary battery. We have to assume an imaginary battery and assume that a current I is flowing here. First, between A and B, when you say A will be your first point, B will be your second point. To the first point, you have to connect higher potential of the battery, and to the last point, you have to connect lower potential. That is also important. You shouldn't interchange. Then the values will, some case okay, in some cases it may change. So, if your current comes here, you can say the current divides at this junction. Let us say if I comes here, divides into I1 and I2. Got it? And here you can use the symmetry relations. Symmetry relations. Like mirror symmetry, there are different kinds of symmetries are there. You can say, in this case, if you observe, according to one of the symmetry relations, if the current I1 goes here, I2 comes here, this is the starting point. Ending point, if you observe, same I2 should come here and I1 should come here. So to make this total current should be I. Got it? That means whatever current going in this resistor has to come here without deviating into any part of this two. Any part here it should come across a junction. it can divide into this and this and this 3 more parts, but it is not dividing, so it is coming as it is. Similarly, this current I1 is coming as it is here. That means you can say as it is coming as it is means we can consider that there is no connection between these junctions. So you can ignore this. You can ignore this. Is that clear, everyone? And one more point, once I1 comes here, anyway it should divide here into this is I1, I2, I3, I4, let us say. I3, I4. This I3 and I4 should come and join here to give I1. That means this I4, which is going through these two resistors, same current. So these two are said to be in series. And this is said to be in parallel to this. So try to reduce step by step. Yes, can you go through now and give me the answer? So reduce these two into one resistor, R plus R to R. It is in parallel with this R. Find the parallel combination of these two. Then this R, that resultant, and this will be in series. And these two will be in series. So simplify by considering these points. Let's try yourself quickly. This last row is that visible? What is visible clearly, or you want me to write little bigger in font? Is that okay? Yes. Options. The options. This is question number 25. Yeah. First option, 2R by 3, 8R by 7. Third option, 7R by 3. Fourth option, 6R. 8R by 7. Any other answers? Any other answers, or everyone has got the same? Right. Let us check whether it is okay or not. So let us try to what I have to do. Mark the point A here, and because we have disconnected this, ignored this, let us draw this first two resistors between A and B, R and R. Now here is one R. Then at this point we can we can replace these two. This you can draw this one. You can replace these two with a single resistor and connect here, and here this resistor. So R, this is 2R, this is R. That is next step. Right. Next step, as this current is coming and dividing here, these two are in parallel. Try to reduce these two into one equivalent resistance. So you can draw this as, what is this? A. From A, between A and B you can replace these two with one simultaneously. So what is that? 2R. Between A and B. This is R, and this will be, what is this say? R into 2R by R plus 2R is 3R. So it is 2R by 3, 2 by 3R. So this will be, you can replace with single resistor of 2R by 3, and this will be another resistor, and these are looking like this. Is this clear now? So now this is R, this is R. So whatever current coming here now passes through all these resistors. Same, that is you can say I1, this is I2. So these three are in series. R plus R, 2R, 2R plus 2R by 3. You can take it as 2R plus 2R by 3 is equal to 6 plus 2, 8R by 3, 8R by 3. So this effective of these two will be 8R by 3. These three resistors will be 8R by 3. If you replace this, what will you get? Again, next step. So this is A. Here you write 2R, and this will be 8R by 3. Join here. This is your B. Now effective of these two parallel combination, these two are said to be in parallel. So what is that? 8R by 3 into 2R by 8R by 3 plus 2R. So this is nothing but RAB. This is nothing but RAB is equal to, what is this, 16 R square by 3. This is 6 plus 8, 14. So divide by 14 R by 3. Yes, 3 cancel, R cancel. So 2 8s, 2 7s is equal to 8R by 7 is your effective resistance. 8R by 7. Got it? That's it. So this is how you have to work out this kind of questions. Already you know, but working is important. So you should be able to do as quickly as possible. So for that, as many times as possible, you have to practice. So sometimes by looking at that, you can directly choose also. Next, the class is up to 10:50. So level 1, exercise 1. Have you completed questions based on a combination of cells? All questions? You have that worksheet, right? Level 1, exercise 1 is there with you, everyone. So have you completed all questions based on cells? Level 1, exercise 1. Yeah. So already I have discussed 43rd one. What is that we are having? 45th one, based on combination of cells. 45. So 45 completed, 46 completed, 47 completed, 48. Yes? No? Have you tried? Any confusion? 48th. 48th one. Completed? Anyone has not completed having any confusion? If you raise your hand, you can discuss, otherwise we'll go ahead. No problem. Next. Question number 49. 49. 49. Have you tried? If no, you can say, no problem. Not tried? Okay. See here. What is given here? When a battery connected across a resistor of 16 ohm and the voltage across the resistor is 12 volt. 12 volt. When the same battery is connected across resistor of 10 ohm, voltage across it is 11 volt. The internal resistance of the battery in ohm is. Similar kind of question we have discussed in level 2. Right? When a resistor is connected to one cell, the current is I1. The same cell is connected to another resistor, current is I2. Then what is EMF? That kind of question we have discussed, right? Yes or no? So this is related to that same kind of scenario. So you are asked to find internal resistance, right? So it is given that when a battery connected across a resistor of 16 ohm, voltage across the resistor is 12 volts. Yes. it is from level 1 exercise 1. Level 1 exercise 1 question number 51. Right. So when a battery is connected across a resistor, there is a battery connected across a resistor, then voltage across the resistor is 12 volts. Across this resistor, you can say V1. So V1 is 12 volts. If this resistor is having 16 ohm, so when R1 is 16 ohm, V1 is 12 volts. Right? And the same battery is connected across a resistor of 10 volt. Voltage across it is 11 volts. Let's say this is R2 is equal to 10 ohm. Then if R2 is 10 ohm, V2 is 11 volt. The internal resistance of the battery. What is internal resistance of the battery is the question. So it will have some EMF or internal resistance. Same EMF, same internal resistance. So what is internal resistance of the battery is the question. So when you connect this, a current will be drawn from this I. So we can say terminal potential difference across this is nothing but this. So you can say terminal potential V is equal to E minus IR. Here this R is nothing but I R internal resistance. Internal resistance, right? So it is first internal resistance is same, but current, E is also same. What about current? Current is in general, current you can say is nothing but net EMF by total resistance. Total resistance. So net EMF is E, is not given, and resistance is capital R plus small r. Capital R plus small r. Right? If you substitute this here, then V is given, E is unknown. You can take here, you can write it as E minus I is E by R plus small r into small r. Right? V is, in this case, what is this? 12 volts. First case, take this as R1. So it is V1. So V1 is 12 is equal to E. Let us take out. Here we have two unknowns. E is unknown, R is also unknown, right? Let us write the same for the second circuit also and try to find one, then you can substitute in another. So you can write it as E into 1 minus. Are you able to understand this? The equations are clumsy. Let me draw little quickly, neatly. Yes. It is given that you can say as I is equal to EMF. Here you can take net EMF by total resistance R total. So you can take this as E by, here you can take it as E by R plus R. Now you can take this here as 12 is equal to E into 1 minus 1 by R1 is 16 plus R. So into R is there. So you can write it as R by this. So this is 1. Okay. Then another one is for the second circuit. Same way. Potential difference is 11. So 11 is equal to E into 1 minus R by what is resistance? 10 plus R. So further simplifying this, this is 2. 1 can be expressed as 12 is equal to E into 16 plus R minus R. Yes, 16 plus R minus R is 16. So 16 by 16 plus R. Or you can say 16E by 16 plus R is 1. Or further, let us even further simplify this. So if you cross multiply, 16E is equal to, what is this? 12 into 16 plus 12R. So this is 3. Then from second one, you can write this is 10 plus R minus R. R goes, so you can write it as 10 yes, into E. So it is 11 is equal to 10E by 10 plus R. You have to follow quickly, guys. So on cross multiplying this, we will get 10E is equal to 10 into 11. 110 plus 11R. So let us say this is equation 4. So solve these two to eliminate 1. How to eliminate? This is 16E, this is 10E, and this is 12R, this is 11R. So let us you have to make, if you subtract this, it cannot cancel, add, anyway they will not cancel, this subtract, this also will not cancel. So you have to multiply or divide with any common factors. Then what let us, we have to change this. So what common factor you can divide? Let us say divide this and even multiply this with some common factor. You have to make this at least. You have to eliminate e terms. You have to eliminate e terms. How to do that? If you divide this with 8 throughout 8, what will you get? This is 2e. Throughout, if you divide with 8, that means actually speaking, you have to take here 8 by 8. Throughout, if you divide 8, it will be 2e and this will be 10. So to make this also 2e, you have to divide this by 5 throughout. So then you can try to eliminate e. Try that way. Try that as time up. I'm winding now. Try this yourself and get the eliminate e, then get a small r. Okay. So we'll check tomorrow your answer.
Hello guys. The previous question which we were discussing, I would like to clarify here. Just a second, be in line guys. Okay, I cannot share it. Able to see the screen? I have shared a white screen, whiteboard. So, okay, just let me check the settings and I will get back to you guys once again. Right, guys. So I hope it is displaying for you all. So in the previous one discussion, I have asked you to try to find the internal resistance. Okay. So I have given you two equations there. I have given you two equations and I have asked you to simplify that by EMFs also same. So that means we can this belongs to the same cell, so we can equate them. Then hence we can get the internal resistance. So what you can do if that is the case, so you can take this as 12 into 16 plus 12 or by 16 is equal to 110 plus 11R by 10. These two are equal, right? So now if you simplify further by cross multiplying, you can write it as um, 12 into 16 into 10 plus 12 into 10, 120 R is equal to, this is 110 into 16 plus 11 into 16 R. This R terms, if you bring aside, what is 11 into 16 and what are these things? So you can take this as yeah. So what is 12 into 10? 120 into 16. 1, just a second. 120 into 16 is 1920. So 1920 plus 120R is equal to, this is 11 into 16. 11 into 16, 176. 1760 plus, yeah, 11 into 16 is 176R, right? So this, you can take this as 120R, 176R. You bring it here and you bring this. Actually, you observe here. So what is? Yeah, if you simplify this, you have only one unknown value, right? And simplifying this, you can get it. So you can try working out this. Try yourself. So what is R from this? So you can write it as 120 minus 176. 176. Um, hmm. Okay, so you bring this here, 176 minus 20, 56 R, 56 R, 56 R is equal to 1920 minus 1760. 1920, sorry, 1920 minus 1760. 1760 is 160. 160. So 160 divided by 56 is equal to 2.8. Hmm? So our here if you see the options are not given in decimals, they are given in fractions. So from this you can write it as R is equal to 160 by 56. Okay. So to simplify this, can you say simplify with in fractions only, have to keep it. So 2, 2, 4, 2, 8, 2, 8, 0, and mm, so here 2 ones, 2 fours, 2 fours, then uh, 2 sevens, 2 20s, right? So it is equal that further you cannot cancel, so you can say it is equal to 20 by 7 ohm. So you can say R is equal to 20 by 7 ohm will be the internal resistance. So you can simplify this way. So uh, what I would like to convey further here is, instead of dividing this with some letter and some number and dividing this and to make this as common number, you can simply, because E is same for both the sets, so you can find write the expressions for E and equate them, because E is same. E is equal to E, so equate them, then you'll get it simplified and try to get the answer. Okay, that, so your final answer should be R is equal to 20 by 7 on internal distance. Okay guys, so try to work out the other questions also to give the clarification I have just started this, restarted this once again. Okay then, take care everyone and practice other questions. If you have any doubts, you can post me back.